Welcome everybody to this version of our chapter review. And here we'll go through the problems on our review, preparing us for the mid-chapter summative. So we'll do the first two. Number one, we do want to try to factor this again, as has been our habit. So notice our 16 can be written as 4 times 4. Again, we're looking for matching pairs. And again, pairs because the index here is the number 2. And also notice my x to the 4th can be rewritten as a set of x squareds. My y to the 7th can be a couple of y to the 3rds with a leftover y value. And everything I have doubled, right? We're getting in the habit of circling, and all of these things get written outside the front of that radical. So it looks like our answer here would be 4x. Come on, my pen, keep working. 4x squared y cubed times the square root of y, and that's your leftover guy here at the end. So our second one, before we continue with that, we do want to combine that 8 and the 5 together to give us a 40, just to rewrite things, and combine our x cubed and our x to make an x to the 4th. And now here we probably want to work on this 40, right? We can think of that as the square root of 4 times the square root of 10. And then also it'll be the square root of x to the 4th. And like we did before, we could factor and write smaller numerical values, although I think we see right away this is the whole number 2. That over here, with the x to the 4th, that's obviously made up of 2 x squared pairs, which then would be written factored out front, we shall say. And then the only thing that's left underneath there is your square root of 10. There is your final answer, that 10 cannot be further factored into a matching set of pairs. As we start this one, we want to factor our 24, since we cannot just add the 24 to the 250 and get like 274. So as I'm factoring 24, I know it divides by 2. I have 12 left. As I'm thinking about working on that 12, 12 divided by 2 is 6. And my 6 can be further divided into a 2 times 3. Again, my index is a 3. I'm looking for groups of 3. I happen to have one. And we've learned that we can factor that number out front. So I'll rewrite the first one as 2 times the cube root of, and what's underneath? The leftover number of 3 there does go underneath. Also do the same thing with 250. That's quite a bit larger number. But as I am looking for sets of 3 or perfect cubes underneath, I know that 2 times 125 makes 150. And if I have my handy-dandy reference sheet nearby, I see very quickly that 5 cubed is my 125, which is a great number to use here. So this will bring a 5 out front. This will bring a 5 out front. And let me write cube root of what was left over here, my 2. Now, trying to add these together, having a look, oh no, the cube root of 3 and the cube root of 2 are actually different. So essentially, right here, I have what I'm going to have to leave for my answer. I cannot add the 5 and the 2 because the cube roots are 3 and 2 respectively, and they are not exactly the same. So while it's not quite a non-answer, I actually cannot carry out completely the addition here. For number 4, that will work just like if we had x cubed times x to the 4th equals x to the 7th. In a question like this, we simply add the powers. So my mathematical work here is going to involve adding these two fractions. And to do that, I think we realize we need a common denominator. So to rewrite both of these fractions, I see that number will be 12. And my 3 gets multiplied by a 4, so does my numerator. That'll give me an 8 in my rewritten form. And to convert the other one, I have to multiply by 3, both top and bottom, to match my 12. That will make this fraction have a 3 in the numerator. And now I can happily add my numerators and get 11 over 12. And as it turns out, that is my power. And if I simply write the x as my base, I've got my final answer for number 4.